So here's how you solve it. Now you see it from the screen for like a second. Let's go to the next one. Orangeade and the other one, Berry Fruity. Wasn't it you guys that asked yesterday why I used just the white? Why do I use these? See what I mean by using the whiteboards? How much more space I have? Yes, ma'am.
I think there's blood on my desk.
That's kind of gross.
Okay, sorry.
I don't know, that's like gum.
Why don't we just switch desks?
Okay, good idea.
All right, so when you look at this problem, I started working this last hour. I started working this stuff off last hour in Flex because I know a lot of people kind of hit the wall with on Orangeade. Now, what I want you to think about, this problem is asking you to maximize your profit. So when you're talking about maximizing profit, you got to look into what profit do you make. Well, you're making 50 cents on the, was it the orange, I believe? OR plus 40 cents on the berry, and that is our the berry fruity, yes. So that is our overall objective, is to make some money. Now, when we get into this, this is the problem that I told you have to worry about converting from gallons into quarts. Since they're mixing all this stuff in terms of quarts, I convert the gallon amounts, the parameters that I'm given. You know, I have 150 gallons of raspberry juice and 125 gallons of orange juice. I convert that into quarts right away. It's easier to convert down in units than it is to convert up, because you're not worried about fractional amounts then. Okay? You've heard that before?
Why do you have to convert into quarts?
Because you see how the rest of the problems talk about you're taking 1.5 quarts of this, 2.5. So that's why it's always easier to work down a unit than it is up. You can convert 1.5 quarts into, I don't know, some fractional amount of gallons, but then you got to deal with fractions and you all love those. So you have two parameters of things that you are constrained by. Your constraints are how many gallons of orange juice you have and how many gallons of raspberry juice you have. So you know you have 500 gallons, or excuse me, 125 gallons of the orange juice, which means it's 500 quarts of the orange juice. So this is going to be the OJ available. And the other one is 600 quarts of the raspberry available. Okay? Those are the two top amounts that I have. From there, I go back and say, well, each drink uses a specific amount, or a specific quart amount. Well, in the orange drink, it uses 2.5, and the other one uses 1. Uses 2.5 quarts and 1 quart of orange juice. The other one is, as far as raspberry, is 1.5 and 3 of the berry. One of the worst things about this problem is the fact that they're talking about using gallons of orange juice to make Orangeade and gallons of raspberry juice to make Berry Fruity. The names are so similar. I don't like that part. Yeah?
Are you at the 500 and 600?
It's telling you that it starts with 125 gallons. So that's why I said we want to convert it to quarts. That way all of our units are the
Yeah,
same.
I should know where. I didn't know where I was supposed to convert it. I don't know. I didn't understand how when I was reading it.
That's okay. So from here, do we agree it's going to be first quadrant problem again?
No.
Oops. It's got to be first quadrant. And then we just start plotting. I use the orange one first. When we cross or cover and solves, we cover and solve, what do we get here? 200, 500? That's our first one, moving inward. The second one is at 400, 200.
No, 600. Yeah.
No, cover here is 400 and 200. I did, this one was 200, 500. This one will be at 400, 200.
Isn't it switched around? I thought raspberry was X plus 3Y, and then orange was 2.5X plus 1.5Y.
What you're doing here is you're mixing them per each drink. I have to put it in terms of how many each drink uses of the orange juice. So in the orangeade drink, it's using 2.5, and the berry, it's using 1 quart.
I was doing the different drinks, like the raspberry drink. I used the components for that, and then the orange.
It's a very, and I bet you the reason you did that is because they sound so similar. And that's what's a crummy problem in this one. So I harken back to the idea of, can you do did we do okay on the file cabinet problem?
I didn't see the answer you got for that one.
I think it was 2.9.
I got 2.9, but when I put it back in, 20 and 0 was more profitable.
The 20 and
You
0.
can't use it
It wasn't
out
the
of the,
point to use.
out of the whole thing right there.
But I can just totally just use that.
But it won't fit on your floor space. Remember you had that other problem you have to worry about. Are you drawing your arrows on your graphs, or are you just
Yeah.
plotting other points? All right, well, I'll look at that one in a second. I bet you just overlooked something. Yes, sir.
Yeah,
Like, that's these problems, like, almost all of us have in the answer sheet where the 2 lines cross, and we just assume that that's.
Don't, because there will be the time it doesn't. So what do you have, 400?
oh, okay, that's
You should be
it.
able to line them up.
Yeah, because this won't combine with this.
So, did you see it?
Yeah, I got you.
Okay. Thank you for showing that real quick. So now you have the intersection of those 2 lines. Once again, does everybody see how I've got a variable with a coefficient of 1?
I see.
So that means B is 500 minus 2.5. So when we substitute in, you get 1.5 plus, or B, excuse me. This is OR. 1.5 OR is plus 3 times 500 minus 2.5 OR is 600. So when you do that, you get orange is going to be 150. So that is the first part of this ordered pair. When you substitute back in, whatever, you get 125. So the 4 spots you have to check then, well, 0, 0, you gonna make any money there? No, so you only have to charge 3 of them. 200 and 0, 150, 125, and 0, 200. And that all goes in your cost thing. I thought they making a lot of money here.
I thought it was asking, yeah, none of these people are gonna make it.
No.
I thought it was asking like which drink they should make more of.
You are finding that. You're finding what they said. How many of each drink should they make in order to maximize their profits? Well, when you maximize your profits, you're figuring out which set of these, which one of these combinations make you the most money. Well, and this.
So why wouldn't you take like oh, okay, because you have the amount of raspberry. I thought it was talking about like you want the amount of like fruity berry and orange. This is a silly problem.
Yeah. Okay. Yes, sir.
Was the max 150, 125?
Yes, sir. Yeah, it worked. It should work out like that. Now, the canning problem. Be honest. Anybody get close? Look at the last one. I don't know why it did that. I don't know why it was doing
It was like warning, do not proceed. Like I don't know.
Okay.
I should trouble with variable. What's in it?
Yes, sir.
I got 180x plus 15y equals minus.
For the next, for number 23? Oh, okay. I was just wondering if anybody had gotten there. Because I know that in 23, not only is it a little bit more difficult because it gives you that third equation that comes off the problem, but it's asking you to be able to round and assume you know what they're doing here. So if you had gotten through this problem, you had a decimal for an answer, 4.6 something, and you went, I don't know if I'm doing this right, you did it right. So I know a couple people did get this problem right, even though it looked nasty with the fraction to start with. So home canning. And don't make fun of people for growing tomatoes.
Less than $40.
What?
They're spending like 15 minutes.
I know. There was a time we planted a cherry tomato tree once, or not a tree, like a cherry tomato bush. But I kind of kept feeding it Miracle Grow for like a month straight. By the time at the end of the year, we had thousands and thousands of cherry tomatoes. Not like little cherry tomatoes, like Roma tomatoes almost. When we pulled up the root at the end of the year, the root was the size of my thigh. It was awesome. The thing was taller than me. It took over our whole back area. We had probably 2x4s.
You eat the cherries.
Oh, they were great. Fantastic. Anyway, you have 180 tomatoes and you have 15 onions left over from your garden. So you know you have 180 tomatoes to worry about and 15 onions. We know that right away. You want to use them to make tomato sauce and salsa. So you're going to make tomato sauce.
Is that a tea?
It is. And salsa. I've always made teas with a tail. I don't know because I don't know.
I just don't use the blood. Oh, that's a tail. It is a tail. Just
You know that you also know that a jar of tomato sauce takes 10 tomatoes and 1 onion. You know that the jar of salsa takes 5 tomatoes and a quarter of an onion. So if I'm looking at dealing with all tomatoes in this line, that means I have up to 180 tomatoes to use. If I look at my onion line, if you will, excuse me, this is my tomato line. It kind of sometimes helps visualize out. I have up to 15. Yes, sir.
when I was thinking about it, the tomatoes don't really matter. It's just about the onions, because no matter what you do, if you listen to the onions, you're not going to get above 180 tomatoes.
Right.
So you could like not even include that.
So don't use tomatoes in your salsa.
That'd be a very boring salsa if it was just onion. Yeah.
Is there just tomato and onion in the first?
It's a really boring salsa to begin with. So here's what we have. I know that to make tomato sauce, I need 10 tomatoes, and to make salsa, I need 5 tomatoes. To use the onions, I need 1 here and a quarter here. The salsa, what's happening here is the tomatoes, you have 180 tomatoes, you have 15 onions. The tomato stuff uses 15 tomatoes. Yep. The salsa was using 5 tomatoes. In the onions, the tomato sauce used 1, and in the salsa, it used a quarter for using up to 15. You have to have, it's all positive values, you can't use anything negative, but the trick here is the farm stand wants, use at least 3 times as many jars of tomato sauce as jars of salsa. So this is the trick part. A tomato has to be 3 or greater than or equal to 3 times the salsa, and remember, everything is going to be positive. And I have if you recall yesterday when we did that problem that had that diagonal component, one that was not in standard form to find the intercepts, remember we plotted that last. So if you guys got this far and you graphed this, did anybody get 12, 12 and kind of said, there's my max? What's that? You got that? Okay. Then you didn't do this part yet. You forgot about this one. So when we get into this, your 12, 12 spot is right. But you have to figure out where this line intercepts everything. So we go first quadrant. I went tomato and salsa. Covering and solving, I have first intercept of 18, 36. We are working inward. The next one is at 15 and 75. Also working inward. And now we have to figure out where those 2 lines intersect. Once again, we have an intersection point that works out halfway decent because I can say that T is 15 minus 0.25 S. I'm saying, yes, sir.
How do you get 75 and
Cover and solve. 15 divided by 0.25 is 75.
I calculated 60.
Yeah,
So you sure 15 times 4.
Oh, well, I guess it doesn't really matter because that point doesn't matter anyway. So, sorry. All right, 60. Thank you. No one else told me that was wrong. Thank you.
you're lying to us again.
Are there any problems where we use anything other than the first quadrant?
Not that I can remember. I don't think we have any of them. None of these word problems work out of first quadrant because it's kind of like an,
Yeah, basically.
unless you want to talk about a gambling problem, because you can lose money. We can make a real word problem out of our Powerball simulator that I'm still running.
I'm not scared.
I'm not scared. So when you do your system of equations at this point here, by using substitution again, because t you can get by itself relatively easily, you have 10 times 15 minus 0.25 s plus 5s is 180. When you solve that all out, you wind up with an ordered pair here at 12, 12. Okay? Now, we have to figure out where that third and final constraint comes into play. If you recall from yesterday, when we did this one in class about the machine one, where you had those 3 equations, we also looked at kind of like a test point to figure out where that line is going to lie, above or below. Well, since this one, t is greater than or equal to 3 times s, what I'm going to do is just pick a value for t. I'm going to move this down here and say my value for t to test this equation is at 12. Now, if t is equal to 12, what is s equal to?
4.
Good. So that means that if t is 12, s is 4, which is about right here, right? Just rough guessing it. Do you now see how it's below that 12, 12 spot? So that line's going to be going through here. And once I get rid of these little dotted lines, it's really working cleanly. Once you start to look at, it's got to be moving up in here. You're in this 4-sided figure now. You have to pick this spot where they intersect. Where does t equal 3s intersect the 60 and the quarter one? Okay? And that's where you get this weird value. So you have to look at the intersection when t equals 3s and t plus 0.25 S is 15. So when you set that up, you get 3.25 S is 15. You get S equal to 4.6 something. Can I have a decimal amount of jars of salsa? No. And if you went more than that, you'd be over exerting what you're allowed within your parameter, right? So you have to use less than that. And that's where you get the 14, and then you substitute back in and you get 13 and change, and that's where you get 14 on the other one. You have to round the other way on that one too. Whenever we have a problem like this, if we have a problem this complex on the test, this, it's okay. This problem here,
It was me.
the intersection here is not going to be a decimal equivalent that you have to really, really concern yourself with. It's going to be cleaner, okay? You don't have to worry about any rounding error. The idea here was, can you get to this 12-12 spot and identify if it's going to be above or below that point? That's where it comes in. And then another, yes, sir.
So are we done with this problem?
Yeah.
What's the answer?
It's at this point here. It winds up being 4 and 14. With the rounding parts on it.
What was it if you put in 4.6?
I think it goes over. Well, I have to remember what it was. Wasn't it like, I don't remember, it wasn't it over 14 again? That's why you had to round down. I think that's how it worked out. It was like 14 point something. I don't remember what the decimal was, but that's why you have to round it back towards.
Why does it say like the pharmacy wants at least 3 times as many jars of tomato sauce?
When you're a purchaser, if you're ever at if you're running a purchasing point and you know that you sell more of one item versus another, you go to your supplier and you say, hey, I need more of these than these. When I was in management with Home Depot, that's kind of what we would do. You know that you sold X amount of certain type of piping, and you would always keep on hand more of this style piping than another style piping. You have to know your trends in what things are selling versus what things aren't, as well as seasonality of certain items. This might be a football season. They want more salsa than tomato sauce. People are having chips and salsa while they're watching games as opposed to making spaghetti.
So
You learn, it's not inherent to this problem, it's inherent to each specific site.
So why does, I mean, obviously you make more off of a jar of tomato, or
Right.
a jar of tomatoes.
But in volume, you move more salsa, so you may not make as much profit on a salsa jar, but if you're moving more of it, you will make more money than you will on tomato
No,
sauce.
but you can't have, like, you can only make a certain amount of
Right.
tomato sauce.
Right.
And so why not just say, well, I maximized as much tomato sauce as I
Right.
could make, then I made whatever I could out of the salsa.
But then it comes into the problem of you're sitting on inventory that's not selling. Have you taken an econ class yet?
Not yet.
Take an econ class because you're going to do awesome in it. Seriously, your mind is already thinking that way. Take an econ class, you're going to love it.
All right.
You're thinking that route right now, and I'm telling you, because I was in in management like that. You'll start to see those trend things, and you're going to start to pick up on every situation is specific. And you're right. Well, I can make more money by just selling this, but if you're making money, you will. But if you're sitting on inventory, you're holding up floor space, shelf space to be selling something else that's going to move faster. And you want that turnover. You want that return on the investment that you're making because you're going to make more money in the long run.
If they want more jars of tomato sauce than they do salsa, so why not just say, well, I'll make as much or tomato sauce as I can, and then I'll just give you whatever salsa I can make. Why do they need 3 times as much salsa?
Because the farm stand wanted it. How's that?
Well, there is no salsa to sell to customers, so then they're more profitable.
Right. So here's what I want for today then. I have 4 more of these. Yeah. This is the last 4 of these to do. No, it's not multiple choice. It's just giving you the answers in case you screw up. You get an idea. You need to flex fast up yourself. I'll go over this stuff with you guys on Monday. I want to flex fast.
You do?
Yeah.
I know I do what I'm doing too.
Yeah. It's like, was the whole class going to show up on Monday?
Yeah, it's happened every day.
So let me talk to you guys about what on these things. number 5.
Yeah.
That's the science.
Oh my god, you know something like that, everyone's just like, you know, something about like, you know, talking about like,
But 1 and 2 are multiple.
that's what's
Well,
going on.
yes, ma'am.
It's like in my head.
Huh?
It's got stuff in my head. But I heard it like last meeting, you know, so I'm like, that looks super stuff.
So let's take a look at how these set up. So I'm going to give you guys a little bit of time to try this on your own here. On these first couple of problems, as you read through them, they're asking you to maximize specific things. In the first problem, if you read through it, it says, in order for them to maximize profits, how many tourist seats should they sell? So the objective here is to maximize your profits. Now, when you maximize your profits, you guys are always finding that set of ordered pairs, right? Now, one of the ordered pairs deals with the tourist seats. So that's what you're looking at doing. Figuring out what is the value of the tourists. Yes, sir?
Does people actually make money this time?
Don't know, maybe. Yes. So, if you look at this first one, there are a couple of different wording in this. Let me help you get started on it. It says you need to sell at least 5 business. At least. Is that a greater than or equal to or less than or equal to? It's greater or equal to. So you've got your first class tickets. Oh, excuse me. I'm looking at business class has to be greater than or equal to 5. And your first class tickets have to be greater than or equal to 9. How many seats are on the plane? 30. So that means business class plus first class has to be less than or equal to 30, unless people are sitting on the wings. Their profit, your overall objective is that you make $40 on the business and $45 on, I don't know why I used that. That should have been a T for tourist, excuse me. It doesn't really matter. And that's your overall. Now here's the trick. We agree this is a first quadrant problem, right? We agree it's a first quadrant problem, right? But if we're looking at a first quadrant problem, B and T for tourists, my value of B has to be greater than or equal to 5. So I'm starting past 0. I can't have 3 of them. I have to have at least 5. Same thing with the 9. I gotta be here. So I have an ordered pair that it meets, because it's out in this direction now, of 5, 9. What are your x and y intercepts now for the plane restriction?
Can you set parameters, just like subtract, or for T, you subtract 5 from 30 and say, I can have up to 25 seats on tourists?
What do you think that is? That's exactly what it is. If you have 5 tourists, if you have 5 business class people, that means you've got 21 tourists. If you have 9 tourists, you've got 21 first class people.
So you don't even really need to solve the problem at all, you just need to know that.
In this instance, you don't really need a graph. You're right. But it works out because those are your 3 ordered pairs. Yes, sir. Oh, that should be 525. Thank you. Thank you. Sorry about that. Thank you for pointing that out. Okay. Now, as you get in the rest of them, number 2 is very similar to what you guys did with the cabinet problem. There aren't very many constraints to it. Problem 3 does have a weird constraint. So I want to kind of give you guys a heads up on number 3 real quick here. Number 4 is very simple. You'll be able to, if you can get number 2, number 4 is just as easy. Number 3 though, if we go on and look at that, number 3 they're talking about first class and tourist class. That's where I got that value of F in my head there. So once again, you want to maximize your profits. So you make 26 and 24, so you make $24 for first class, and you make $26 for your tourist, and that's your objective. You need at least 12 first class. So what is that going to look like? Yeah, so first class be greater than or equal to 12. And then the other one says you have to have at least 16. So tourist has to be greater than or equal to 16. Here's where it comes into a little bit weirdness. It says that the plane can't hold any more than 50 people. So that means the combination of the seats has to be between less than or equal to 50. Now, here's where you have to kind of start thinking about, is there an upper level of number of seats you have for first class and for tourists? Well, if you're starting with 12 first class people on the plane, how many more can you add to it before you have too many people? How many? 38. So if all 12 people get on the plane in their first class, there's only 38 seats left for them also to occupy. Do you agree? So that means that you're bounded between 12 and 38. Same idea here, because it doesn't say that you have to have a certain amount of each one of them to go. It just says in order for it to run, it has to be more than this or more than that. So it has to be less than or equal to 34. What this problem does is it's basically creating a rectangle with your horizontal and verticals, and you've got a diagonal cutting through it. You just got to find those points. And similar to what the first problem was, you can probably start to see where your ordered pairs are going to wind up without even graphing, to tell you the truth. Okay. Like I said, number 2 and number 4 are very straightforward. There's a cost involved. There's a number of machines there. There's a number of tickets available. Number 2 is just be horizontal, vertical with a diagonal. And number 4 is just two diagonals. Okay? These should be a lot easier than the ones we've done so far. I'm not gonna lie. Okay? Time's yours. Go ahead and get started. I'll walk around and give you guys a hand here and there. But that's kind of where we're at for today. Oh, nuts. I never pressed record.
Wait, will you look at number 1?
We'll watch the other class.
Sorry about that.
Will you go back, please?
What's that?